Everybody say good morning.
Good morning.
All right, here we are. We're going to construct the Euler line. So we're going to start off by drawing a triangle here. Any triangle you wish. Don't make it equilateral when you practice because the centroid and the circumcenter will be the same point. So start off with a scalene triangle, a triangle with 3 different side lengths. Stretch it out a little bit, that's what I'm saying. All right, the first thing we should do is construct the perpendicular bisectors. That's the easiest one to do. And we're going to save a little bit of time. We only need 2 perpendicular bisectors to do this. Okay? And so to find the circumcenter. So what I'm going to do is I'm going to adjust my radius more than halfway. Notice this, I'm going to make my arcs really light because I only want the perpendicular bisectors to stand out, and I need to find the midpoints. I need my bisectors. Okay, so I'm going to draw the bisectors really lightly here. Oh, I don't have a pencil. Thank you. All right, so I line up the arcs here. This you've done a couple days ago. I'm going to draw the bisectors. Look at this. Watch this. This is B1, bisector 1. I use A1 for altitude 1, B1 for bisector 1, and M1 for midpoint 1. All right, which makes sense. So I just have a perpendicular bisector. The midpoint's going to help me get the median. The bisector is going to help me find the circumcenter. All right, and now I want to do another perpendicular bisector here. I have to enlarge the radius because I need it more than halfway. Draw it really light. Intersect the 2 arcs, like so. Draw your bisector. Okay, and right now, once I draw my bisector, I found the circumcenter. Okay, there's the circumcenter right there. So this is B2, this is M2, and right here where the bisectors meet is called the what, everybody?
Circumcenter.
Okay, so you label it as you go, because if you don't label it as you go, you kind of forget what you've done and you get lost a little bit. Now what's cool about this is that once you get your midpoints, the medians come easy because the median is vertex to midpoint, and that helps me find the centroid. So if I take my vertices A, B, and C and connect it to the opposite side on the midpoint, I get a median. And I'm switching colors so it pops out, you can see it. The median, excuse me, the centroid is the balance point. Okay, so to find the balance point inside the triangle, you got to intersect at least 2 medians. And I just found it right here. Here's my centroid. Right here. That's the balance point. Centroid. Everybody say balance point?
Balance point.
All right, that's the centroid, and it's the balance point. Okay, now, so the Euler line is right here. Here's the Euler line right there. It runs through those 2 points. But I got to find the 3rd point called the orthocenter. Okay, and things are starting to tend to overlap. So if you have a 3rd color, you know, put a 3rd color in there like blue, so you can see things better. Or if you can just handle it in pencil, just go for it. I need to intersect the altitudes, and every altitude takes 3 arcs. So I'm going to construct the altitude through B first. I have to intersect the opposite side twice. Okay, now kind of hard to see, so let me highlight them. Here's one, and here's the other one. Now if I use the same radius, I'm off the page. So I shorten it up. I intersect 2 arcs on the intersection points, and I get my first altitude. I'm going to put it in blue through B. Now an altitude is a height, and it's perpendicular to the side. I'm going to call it A1. That's a right angle because it's perpendicular to the side. And I need 2 altitudes. So I can go altitude through C over here, or I can go an altitude through A over here. It really doesn't matter. I'm going to go through C. To do that, I need a large radius here, so I'm going to have to really expand it. And this may happen to you. It's happening to me right now as we speak. I have to intersect the side twice, and it intersected here, but not over here. So no big deal. You just make the side longer, because you need to intersect the opposite side twice. So you make it longer, no big deal. So I found my intersection point here and here. Now if I use the same radius, I'm off the page again. So you shorten it up. No big deal. Here and here. And your altitude is through that vertex. And whoa, lo and behold, it's actually equal. It goes right along the side. That's because this is a right angle right here. Just got lucky there. Okay, there's A2. So where do these meet? A1 meets here, and here the A2 right here, so it happens to be right on a vertex. That's very, very uncommon, okay? That doesn't happen very often. There's your orthocenter. Okay, now if I was pretty fast at this. Typically I'm more precise and I slow down and I pay attention more, but anyways, the Euler line goes through all three. Anybody have a green pen over there or something? Here, purple. There we go. Purple's good. All right. Watch this. They're collinear, which means all 3 points. What? All 3 points
on the same line.
So here's the circumcenter. There's the here's the circumcenter. There's the centroid, and there's the orthocenter. I line them up, and lo and behold, they're collinear. The purple line is the Euler line. Contains all 3 points, and that's the goal. There it is. It goes through the circumcenter, the centroid, the orthocenter. Okay? It doesn't matter. Thank you very much. So that's it. We would need to practice that right now, and after we practice it once, then we could do it on graph paper with your set of points. Okay? All right, let's go to it. Let's practice.